34 integral from pi over 4 to pi over 2, 1 plus cotangent x over 4 minus cotangent x dx. This one is a complicated one, I will say, right away. Immediately, what I thought to do was maybe change things in terms of sine and cosine, but that didn't really, well, I abandoned that method, but let me just show you what happens. So I'm going to pretend this is an indefinite integral first. So this will be 1 plus cosine x over sine x, and then 4 minus cosine x over sine x on the bottom like this. So if I multiply by sine x on the top and the bottom, then what I get on the top, I get sine x plus cosine x, and then the bottom, I would get 4 sine x minus cosine x. So I don't see a substitution like u be the bottom, and then du would be 4 cosine x plus sine x dx. The problem is this 4 is in the way. I can't just do a fourth du, because if I do that, this 4 would go away, but I put a fourth over here. And then there's no a fourth on the top. So this makes it complicated. Okay, there might be a way to do this, but I just abandoned this method right away. And I started to try something else that might be more complicated, actually, but I proceeded and persevered through it. Okay, so let's let u be cotangent x. Du would be, what is du? That's minus cosecant squared x dx. Okay, I don't see a cosecant squared in the integral, so maybe let's rewrite this as, well, 1 plus cotangent squared theta is cosecant squared theta. So this is, oops, I keep hitting the erase button. Okay, that's my du by the Pythagorean identity. And then this is just 1 plus u squared dx is my du, remember? So then du over 1 plus u squared with a minus sign is dx. So let's substitute. What happens? I get 1 plus u over 4 minus u. Then dx is du over 1 plus u squared with a minus sign out in front. So I can pull that out in front. Okay. Let me make this a little bit nicer. Okay, limits of integration. When x is pi over 4, we plug into our definition. U is 1. When x is pi over 2, u is 0. Okay, so we can flip the limits of integration and get rid of that negative sign. Okay, so now we have this. Let me write it a little differently. 1 plus u over 4 minus u, 1 plus u squared. Okay, this we know the technique for. It's a rational function, partial fraction decomposition we can do. All right, there is a nonlinear term, so it's going to be not that nice, but let's persevere. I said this one was going to be a little more challenging. Okay, and then let me erase this. I need my definition of u because I need a back substitute. Actually, I don't need a back substitute because it's a definite integral, so I can get rid of this. Okay, that's a benefit of changing the limits. Okay, so we have 1 plus u over 4 minus u, 1 plus u squared. This is a over 4 minus u plus b. I'm not going to use x. Let's use, oh wait, actually we have to use u. B times u plus c over 1 plus u squared. Multiply both sides by the denominator. 1 plus u is equal to a times 1 plus u squared plus, in parentheses, bu plus c times 4 minus u. Okay. Let's expand everything out. We can plug in 4 to get rid of stuff, but let's expand everything out first. It might be easier. So usually I mix and match the techniques. A plus au squared plus 4bu minus bu squared plus 4c minus cu. So then 1 plus u is equal to a minus b, u squared, took care of this, plus 4b minus c times u, took care of this, plus a plus 4c. Okay? We can match coefficients and all that, but as I said, we can mix and match techniques. So if I plug in u is 4, let's look back at this line up here. What happens? This whole second term over here would go away. So we would get 5 is equal to 4 squared is 16, so 17a. So a is 5 over 17. Okay? Whoops, let me just erase. Okay? Now, since we know that if we match coefficients now, there's no u squared term on the left, so we know that b must be minus, or a minus b, let me just write it, is 0. So a is 5 over 17, right? So b must be 5 over 17 as well. Equals to b, so say space. And then I know that either 4b minus c is equal to 1, because 1u is 4b minus c times u, or I can do a plus 4c is equal to 1. Take your poison, doesn't matter. Let's just do a plus 4. Actually, let's do 4b minus c is equal to 1. And then I know that b is 5 over 17, right? So 4 times 5 over 17. And then minus 1 is equal to c. So then what is c equal to? Oh boy, okay. 20 over 17 minus 17 over 17. That is 3 over 17. Okay. We have a partial fractions. So let me erase this to make space. Shift this up to here. And then, okay, here we go. 0 to 1. A was 5 over 17 over 4 minus u. Okay, plus B was 5 over 17 as well. 5 over 17 over 1 plus u squared. And then plus 3 over 17. This is 5 over 17u, sorry, over 1 plus u squared du. By the way, I split up this fraction into these two right here. Okay, because I know how to integrate these individually like that. Okay. I'm going to erase all this partial fraction decomposition now. You can always rewind in this video. You need space. Okay, so first guy, 5 over 17 with a minus sign, natural log of absolute value 4 minus u. Okay, second guy, I would get, okay, let's do this slowly. 5 over 17, I'm doing the u sub in my head though. I would get half, and then 1 over 1, actually, is 1 plus u squared to the minus 1 power right now. So then this is just, it'll still be a natural log. Yeah, it'll still be a natural log. I'll check right away by differentiating. Don't you worry, I'll double check. 1 plus u squared. Okay, let me double check right now. Derivative of natural log, 1 over 1 plus u squared times 2u. The 2 and this half cancel. I have left u and then the 5 over 17 still there. Yep, there we go. Okay, plus, this is the arctangent. 3 over 17 arctangent of u. Evaluate this whole thing from 0 to 1. Oh boy, okay. Let me start erasing any space. Okay, so let me get rid of this. Okay, let me just erase that. Cutting for some reason didn't work. Okay, sometimes these problems take long, so you got to persevere. This is how we get better, especially on these longer ones, where you persevere through. Okay, and those one technique ones seem much simpler afterward. Okay, so Plug in the upper bound, so minus 5 over 17 ln of 3 plus 5 over 34 ln of 2. Let me just write ln of 2 like that, plus 3 over 17, arctangent of 1, that is pi over 4, okay? Minus, plug in the lower bound, minus 5 over 17 ln of 4. Next term would be ln of 1, which is 0, times all of those constants is 0. So then, and the arctangent is 0 is 0. So that's that. And then this becomes a plus. So then I think that's all we can simplify, actually. So let me double check that's the answer. This is what I got previously. Minus 5 over 17 ln 3. And then I got 5 over 34 ln 2, yeah. 3 over 17 times pi over 4, yep. 5 over 17 ln 4, yep. Okay, there we go. That's the answer. So we started from this thing that had cotangents in it, and then somehow we did a substitution that led to partial fraction decomposition. So that's how I solved this. If you solved it in a different way, please feel free to share in the comments so that other people can learn as well. Maybe if you have an easier technique, great. Please do share. I do want people to see different ways to solve this.